All right, everybody. So if we pick up where we left off yesterday, we need to discuss operations with functions. So if you take that homework sheet and you flip it over, and let's actually jump down to number 17. We're going to start with a nice easy one, just addition. Let's look at what in the world is going on here. Okay, everybody sees where we're at? On the back, number 17. Okay, check this out. So we have two functions here, a g function and an f function. And then they want me to find g plus f of x. All I have to do with these is I'm literally going to take the two functions and I'm just going to add them together. I'll combine like terms if there's any like terms to combine. That's all I have to do. So I'm just going to take the g. So g was 2x minus 4. And I'm going to add to it the f. X to the third plus 5x squared. Combine like terms if we have any. So the left hand side still I'm not touching, right? I'm just, that stays by itself. But then on the right hand side, let's see, I always go with the highest degree and then mark down. So there's no other x cubed, so that's just going to stay. X squared. Oh wow, I don't think we have any like terms in this one. So that literally just is my answer if I just put it in called standard form, right? You start with your highest degree and then work your way down. That's it.
There's an extra x. You're wrong. No. No, Elise. I'm confused. There's an x.
On the right hand side?
You have to multiply everything by x.
The left hand side, yeah, this is function notation. So this we're not, that means just like yesterday, remember how it was just like f of x? Like look at these. See how these are just, that doesn't mean f times x, remember?
Yeah. Then why is that there?
That's just saying, hey, this is the variable that we're going to replace. That tells you, okay, when you go to do, if I want you to find f of 7,
Oh,
right?
because it would multiply out and it would get g of x plus f of x. Yeah, you get what I'm saying?
Wait, I'm like,
I am too.
I don't really understand what the question is.
Yeah. The alphabet, just write it out. And then you're adding.
No.
What is it? Isn't the last opinion? It's like, what's his phone?
I don't understand what do you mean.
No, so look, there's an
No, I get what you're saying, but the x is like you substitute in those for x.
But like you would,
Yeah.
Isn't it?
so like basically,
Yeah.
why don't they just put g of x?
Yeah, wait, what did you say?
Just put the x on the outside and make it easier.
Why is this x right there is the question? So that's just how function notation is set up. So this, let's go back to just a single one. So remember, that's the name of the function. So this letter out in front is just a letter naming the function. I'm just calling this one G. I could call whatever I wanted. And then what is in here, that is the variable that you're going to replace. So that's just how function notation works. We have the name on the outside and what variable I'm going to replace goes in here. So this is just my regular schmegular. There is your g of x function. So if I wanted to find, forget all of this, if I wanted to find g of 3, remember what that means. I'm replacing this x, that variable, and now I'm going to plug in the new one, 3. So that would be 2 times 3 plus 4, right? And then I'd get 10, right? If I was doing something like that. So here, now they're like, okay, cool. So we have a g of x function and we have an f of x function. So I want to know, well, if you took those two functions and added them together, they're still both in terms of x, right? They're still both using that variable x. So if I wanted to, I could evaluate the G plus F function at some other number. So this is setting me up, if I now wanted to find G plus F of 4, I could replace this with a 4, and then I know, oh, that means replace all the X's with 4s, and then see what you get out. Does that make sense?
Oh, so the X is just telling you what you're putting in for X?
Yes. So
Oh.
this, whatever is in this second set of parentheses is what's going to get replaced. So if I now do G plus F of 2, now I'm replacing all of these X's with 2s.
Oh, I got what you were saying.
I was, yeah,
But are you, you're okay now?
yeah, I'm good
Okay.
now.
Jimmy?
Did you learn this in algebra 1 or is this like?
I have no idea if you learned it in another one. I don't remember.
Do most people learn it in algebra 1?
No, we learned this in
I don't remember.
Yeah.
I remember doing this like eight.
The doctor.
We didn't do this.
Good.
Yeah, I did with Dr. Square and then we started with,
No, we did not.
We did not start at this.
We did not start with
No, we did not.
okay,
You
then,
are imagining stuff.
never
right
mind.
Maybe at least just pays attention.
now. No, she obviously did pay attention because she was reading Lou Beluga or something.
Oh, boy.
I'm still in my old book, the bag, like, backpack.
It's hard for me to know what you did or did not learn for so many reasons. One, because everybody came from a different teacher. I know how far you got, and we're in COVID times. So no one knows, like, we're not getting to what we normally get to just because of the nature of things, right? It's just, it's chaos. So I don't know, these last 2 years, it's like a crapshoot, which you have learned and which I haven't. So we're just trying to do our best to put all the pieces back together. So I'm actually glad that this point came up, because you might feel like some of this stuff is like, oh my gosh, I know this. Like, I can't believe we're going over this again. But that's you. And I'm glad that you know it. Enjoy it while it's easy. I can't tell you how many other kids don't know it. So we kind of have to start from square one. So if you are feeling like, oh, can we just get on with it? Just enjoy the ride, okay? Enjoy it. We'll get to the hard stuff, I promise you. Don't rush your way there. Okay, does that make sense? All right. But anyway, all I was supposed to do was add these two functions together, and I did. So I'm done with that one. So let's jump to 20. There's another addition one. So you try it. This one does have some things that will combine at least. So give it a shot. Take your G, add your F to it. You have any like terms, combine them. You have an answer? Go for it. I agree with you. Is that what everybody got? When you add those two, you have a positive 5 and a negative 5. They're going to cancel each other out. So that's it. Try 22 real quick.
Do it.
Okay, we got an answer? Brady, what'd you get?
5A plus 6.
Correct. 5A plus 6. And that's it. So adding is literally that easy. Just take whatever they want you to add together, combine like terms, and you're done. All right. So now what about subtraction? Oh, well, subtraction, you got to be a little bit more careful. Let's rewind back up to, I guess, 14. Is that, oh, no, I guess we will. Okay. So jump back to 14. There we go. Okay. So, I mean, the process is the same, but you got to be careful. When you are going to subtract, I'm going to take the G function. Now, order matters here, right? When it's addition, we don't really care because you're just adding everything. So here, I got to make sure that I take the G function and I subtract the H from it, right? Not the other way around. So we're going to start off with the G function, which is 2n minus 4. Now, here's where kids mess up sometimes, but you won't because you're listening to me right now. You need to subtract the entire H function. So since the h function has two pieces, you can't just subtract 2n. You got to subtract all of it. So you should be writing it like this, minus the whole thing, 2n plus 4. Be careful. So now, again, I'm not doing anything on the left-hand side. I'm just bringing that down. What do I have to do to evaluate this right-hand side? Yeah, so it really looks like this, 2n minus 4 minus 2n minus 4. If you don't put those parentheses, you're only going to have a minus 2n, and you're going to think that that's a plus 4, but it's not. It should be a minus 4. Now I can combine like terms. So when I do that, what do I end up with? Anybody? Nathan? -8. My 2n's just so happen to cancel, but -4 minus another -4 is a -8. Jack?
How do you do the ones with like the fractions?
Oh, I'll get there. I'm not there yet, my friend. I gotta do multiplication. Oh, there's no multiplication one. I'm gonna have to make one up. Oh, that's funny. I don't know how multiplication escaped us. So let me have you try another subtraction one before we move away from it. I guess the only one left is 18. Jump to 18, everybody try that one. Pay attention to who's coming first. It says h minus g, so make sure you start with the h function. Then subtract g from it. Hold on to it for 1 second. Make sure you are subtracting the entirety of the g function. Jimmy, you have an answer or a question? Hold on to it. All right, so I hope you all started off by doing -3a plus 4 minus the entirety of g, a squared minus 1. I hope you then distributed. If you don't have a +1 on the end, you did not distribute. Okay, Zach, what was the answer you got? Jimmy, what was the answer you got? So you agree. So do I. That's good. Check yours. If you had a +3 on the end, you're not distributing. You have to. Okay, I don't know how there's not a multiplication one on there. So if you want to, I don't know, if you want to stick one in somewhere, I'm going to use another piece of paper. Sorry. Sometimes we just randomize it and it doesn't always give you what you want. So let's say f of x was x plus 1. And let's say g of x was, oh, how about 2x minus 3? If I want to multiply these two functions together, I might say something like find f times g of x. And you'll notice if we are going to use the multiplication symbol, which is usually what we do, it's going to be closed. It's going to be a solid dot. There is an open dot, which we're going to talk about later today, and it means something completely different. But this just means to multiply the f and g functions together. Go ahead and try it. Hold on to your answer. Multiply those two together. I will give you a hint, a small hint if you want it. If you have an answer of 2x squared minus 3, you are incorrect, my friend. All right, Jimmy, what'd you get on this one? No, that sounds right. Just doing it in my head real quick. I think that's right. So let's check out what we're doing here. The f function is x plus 1. That's a binomial, so I need to put it in parentheses if I'm going to multiply. And now I need to multiply by the g, 2x minus 3.
Wait, that was all right. It's fine.
I didn't hear what you said. I take it I wasn't supposed to.
Wait,
How?
Wait, what did you say? I don't know if I agree with that.
Two x squared minus x minus 3.
I think it's right. I did in my head, but we'll find out together.
No.
Wait,
Just be patient. Just wait a second.
Oh, it's a -3? Bro, what? I wrote it down wrong. You're gonna learn back to this.
So someone tell me, how do you multiply two binomials together?
Oh, wait.
Jimmy, go ahead.
You gotta like distribute that all.
Yeah, but what's the word? FOIL. FOIL's the word I'm looking for. Yes, FOIL. Remember FOIL?
Yeah.
First, outer, center, last, or first, outside, inside, last, whatever. That's when you have two binomials, you're multiplying together, you got to multiply all those pieces. I mean, you're not wrong, Jimmy. You are doing it. It's basically double distribution. But we have our cool little word, so we might as well use it. So first, x times 2x, 2x squared. Outers is a -3x. On the inners, I got a plus 2x. And then the last, I have a -3. Combine like terms, because I do have some here. And 2x squared minus x minus 3. I agree. So no matter what your functions are, you're just going to multiply them together. So let me give you one more. What if you had something like f of x was, let's see how much you remember with your exponents. Let's say it was x to the 4th plus 3x squared. And let's say g of x was a -x to the 3rd. And let's say I wanted you to again multiply them together. So let's find f times g of x. All right, Zach, what'd you get this time?
12x to the 12th power minus 3x to the 6th.
So the only time you're going to multiply your exponents is when you raise a power to another power. So if you had like x squared and you cubed it, that's when you multiply. So if you are just multiplying, let me just do a little side work right here. If I have x squared times x to the 3rd, let's say, what's that really? X to the 5th. You add the exponents, because if you think about it, isn't x squared just x times x, and then x to the 3rd is x times x times x. So all together, I've got 5 of them. So the only time that I'm going to multiply is when I do something like that. When I raise a power to another power. Now I multiply the exponents. That's x to the 6th. So if I go back to what I'm doing here, I'm not raising any powers to another power. I'm going to multiply -x to the 3rd times x to the 4th. So when I am just multiplying the two bases together, I'm really just going to add those exponents. So it is going to be -x, but now I'd have to the 7th power. And then the -x, these two, that would be a -3x to the 5th. Yeah, because you're going to add your exponents. All right, so there is multiplication. And now let's look at our friend division, which you may actually like the most because it's really not bad. So if we jump back to our sheet with number 13. If you need to divide f by g, it's usually just as simple as literally just writing f over g. So the f function is just 4x plus 3. And I would just put it over the x squared minus 5. Now, occasionally you can simplify this. Most of the time you're not going to be able to though. So that's pretty much just your answer. If it's blatantly obvious that you could reduce it, you should, but these don't go anywhere. So I'm usually going to be done there. We will eventually be talking about the restrictions on the variables. So for example, what are you never allowed to have in a denominator? What's the number that you can't have in the denominator, otherwise like the world implodes? 0, right? You can't have a 0 in the denominator. So isn't there a value that would get me a 0 in the denominator right there? Yeah, if it happened to be what, square root of 5? If you plug in square root of 5 and you square it, you get 5. 5 minus 5 is 0. Uh-oh. So, but that'll be later on. We'll talk about that. But for now, that's literally it. So try 15. They want g over f, so make sure you put the g function on top, the f on the bottom. All right, who's got it? This is a nice one. Nobody? Hey, go ahead. That's it. You can't simplify this, by the way. I know you might be tempted to be like, oh, look, n over n, let me just cancel them out. No, it doesn't work like that. Because this n is part of a binomial. The only time that you can go around canceling things is if you all had monomials or single terms. So for example, so this is not related to this problem, this is just a new one. If you had something like 4x over 12x squared, these are not parts of binomials. This is a monomial. It's a single term up top, single term on the bottom. You could certainly reduce the 4 and the 12 with each other. And you could reduce the x on top of the x squared on the bottom. This whole thing, that would be 1/3. And then if you reduce those x's, what are you left with? Yeah, you'd have 1x left on the bottom, right? 1 over x. So that whole thing would simplify to be this. That is totally different than this. Let me show you. If you had something like x plus 2 over x plus 4, let's say. Don't you dare come in and say, oh, x over x, I'm just going to cross them out. You can't do that. You cannot do that. You cannot cross off pieces of a binomial. The only thing you could do is if I had a whole nother x plus 2 on the bottom and I canceled out the entire binomial. You can't cancel a piece of a binomial or a trinomial or a whatever. If it's a monomial, a single term, so there's no adding or subtracting going on. Sure, reduce if things are reducible. Otherwise, you better not touch that. Does that make sense? What you could do, just a side note, if you had something like, let's say I had 2x plus 4 over 6x, something like that. In my numerator, that is a binomial, but I can factor something out of that binomial. Couldn't I pull a 2 out of the top of that? So couldn't you do this 2 times x plus 2? Isn't that the same thing? You see that? Isn't that allowed? And now I have a monomial with a monomial, and I could reduce these with each other. See how I'm not touching anything in that binomial? That's like sacred. It's like intact. Don't you cross off anything with something on the bottom. But now I can reduce the monomials with each other. So my final answer would actually be x plus 2 over x. Oh, 3x, sorry. That 3 is hanging out there. Anyway, side stories. So operations with functions. Easy enough? Not too bad? So this is an extended block, but I forget what time we get out now. Is it 9:15? 9:20? Yeah, that makes sense. Okay, good. Oh, so we got a good long time to talk about. We're gonna do, I think we're gonna do compositional functions today. Jimmy. Sure. I know.
Well, I don't wanna like fall back, because I don't want to just fall back.
Well, it's recording, so you
Oh,
can
I see.
always just come back and pick it up if you missed anything.
Oh, I go after.
Oh my gosh.
You're gonna miss notes.
What did Mr. Reynolds say?
Fast
Fast
as a
as
flying fish. Aw, that
We're
is
at
so
the
sweet.
horseshoes.
I don't get that one.
The fast as a flying fish one is cute at first, and then I don't remember that.
Oh, yes, okay.
I saw him like shopping. We had the same dentist, and I find him so cute.
And you're
They're
all
gonna be like my grandma. Do they go through your brain?
I didn't have it. I kind of eat.
I'll tell you if you ask me about it. It's like posting.
Are you guys talking about a fish?
No, it's Mr. Reynolds from the junior high. We always say fast as a flying fish. What do you guys think about that?
He said what?
Fast as a flying fish.
Oh,
Yeah.
I know him.
Yeah, he retired.
Did
Year.
No, he retired on Pi Day.
Oh,
Which was
that's
also
cute.
his birthday, because I remember saying happy birthday.
She knows it.
No, I'm saying happy birthday to him.
How
and
long
I
is that?
at the same time. I had like a meeting.
Yeah.
I'm sure you're aware today is 2/2/22.
No way.
Yeah, and
Oh,
we'll have 2/2/2/22 soon.
What is that? Oh, like
The date.
Oh.
Yeah, so
Wow.
what an easy birthday, anybody that's born today, huh?
oh, nice.
All right. Are we ready to talk about compositional functions?
No.
But I have a question.
Sure.
On 16, because if I got negative 2n plus 5 over 2n plus 3.
Great question. So let's look at 16 here real quick. So if I'm going to do G over F, you would have negative 2n plus 5 over 2n plus 3. So the question is, can that be simplified at all? Jack, what do you think?
Well, I just crossed out the negative 2n over 2n, so then you said you can't do that. So I was a little confused.
So should you do it? No, if I said you shouldn't, then you should not. You can't touch them because they're part, this is part of a binomial, right?
Oh, yeah.
Those are together. You can't cross off pieces of a binomial with another piece. You can't touch them. The only thing I could try and do is if I just looked at the numerator and I said, okay, can I factor something out of that numerator? No, I can't pull out a 2 or a 5. Like it does, there's no common factor to pull out. So I can't do anything with them. That is your final answer. If you cross off the 2s, you're gonna be wrong. Sorry to say it, but better you learn now. I'd rather you hear it from me than who knows who. All right, any hoosers. Composition of functions. I'm calling this section 1-5. I think you're really gonna like this. So we are piggybacking off of what we had talked about yesterday with function notation. I have a function, whatever I put inside the parentheses is the new thing that I'm going to insert in place of the variable. Same idea. So what composition of functions is, it's taking one function and putting it into another. So not just adding them together or multiplying them, literally taking one and putting it into another. So that's what this refers to, putting one function into another. There are, and this is another thing that drives me crazy about math, even though I love it to pieces. There's two different ways to write this. Two different notations for it, and you need to know both. I'm sorry. I wish, I don't know why mathematicians back in the day didn't get their act together, but they didn't. So I'm going to show you both ways. It's not bad. I mean, once you get used to it, then it's, you know, it becomes second nature. But it's just awkward at first. It's like, why are you doing this to me? I don't know. I don't have a good answer. So let's try this. We're going to start off with just two functions. We'll start off real easy. So let's have f of x be, how about 2x plus 1? And we'll have g of x. You didn't miss too much. Let's have g of x be x minus 5. So we have already talked about, hey, if I want to evaluate the f function at 7, okay, I would take 7 and I would replace the variable with a 7 and then I'd evaluate from there. Now what we're going to do, instead of replacing it with just some number, I'm going to replace it with the g of x function itself. So this could be written like this. That's one way. So let's do this and then I'll show you the other way that we can write it. So this notation, let's just break this down. This means take the g function and put it into the f function in place of x, or whatever variable it is that you're using. Oh, I'm sorry. Can you see it? So let me show you what this means. I'm going to take everything that the g function is, this whole chunk. Let's use a different color. I'm going to take all of this, and I'm going to put it in over here in place of that x. Just like yesterday or the day before when or whatever day we did it, I replaced that x with a 7 or a 10 or whatever it is I was trying to find, but now I'm going to put all of that in there. So it looks like this, 2, and then I'm multiplying by x, so now I'm going to multiply by all of that, x minus 5, and then I still have that plus 1. Does that make sense so far? Are you with me? Everybody's okay? And now I just evaluate like I have that. Okay, so now I'm just gonna, again, the left-hand side I don't touch, so I would just bring it down, except I wrote all over it. And now I have to distribute that 2x minus 10 plus 1. So my final answer, 2x minus 9. I mentioned there was another way to write this. I don't know why there's another way to write this, but there is. And you're going to see both. And it looks like this. Where should I put it? I'll put it right down here. You know what? Let me make that a little bit smaller. So I know it feels like the word fog, but it's not. So that's not an O in the middle. It's an open circle. Okay, so that's why it's so important to kind of look closely, because if it was a closed circle, I'd be multiplying F and G together. But if it's open, that's a new that's a function operator. So that means take this function and put it into this one. Okay, so still means take the G function and put it into F. The order matters. So if I had G of F, I would do the opposite. Whatever is over, whatever is closest to the X, that's the one you're starting with. You're going to take that one and put it into that one. Whatever it is. Does that make sense? Have you seen this before?
Yeah.
I'm hearing some yes and some no.
I
Okay,
saw the first one, but not the second.
okay. All right, so now let's try going the other way. Let's do, so let's do G of F of X. Oh yeah, sorry. I'm also just gonna note, these are open circles. That's not a letter O. So you'll be able to see when you are looking at your homework or whatever, you will see an open circle. It is different than a closed dot. Closed dot means multiply, open circle means this operation. Okay, so think about what this means. It means I'm gonna be now taking the F function and putting it into the G. So take everything that F is, bring it over to the G function, and replace the variable in the G with whatever you see in the F function. Go ahead and try it, and then you can go simplify if there's anything that combines. Try it. Everybody try it. Give it your best shot. So you always start with whatever one is closest to the X over here. So you're going to take F and you're going to put it into the G. I'm going to rewrite my functions down here just so I have them. And I can draw my arrows because I think that can be helpful. So this is basically what I'm doing here. I'm going to take everything that the F is, and I'm going to bring it over here to the G, and I'm going to swap out that variable for everything that I have in the F function. Jimmy, go ahead.
I was just gonna ask if you're putting an F in where the G of X is.
Yes.
Yeah.
So I replace that one with everything that's there. So when I do that, it should look like this. 2x plus 1, and then I have that minus 5. Does that make sense? And now I just simplify, so that's 2x minus 4. And if you look up, when we did it the other way, we didn't get the same answer, right? They're different. Putting F into the G and putting G into the F are not necessarily gonna yield you the same answer. Is it possible? I'm sure there's times that it does work out, but you're not usually gonna get the same answer. Isn't that interesting? How are we feeling? It's a little weird at first, but once you get the hang of it, it's not so bad. Okay, so I'm gonna flip and I'm gonna give you a couple of them to try. And we'll see how we do. Is everybody okay with this page? Yeah, okay. All right, so let me give you a couple of functions up here. Let's do let's do 3x for f. Let's take g of x can be x plus 2, and let's have h of x. Let's throw an x squared in there. So there's our 3. We have f, g, and h, and let's try some compositions here, okay? And I'm gonna switch back and forth between the two different types of notation, so you kind of get used to both of them. So let's just try something like, let's do G, open circle H. Okay. Let's try. I'll give you 3 to start with, and then we'll go. Jimmy. Yeah. I would not do any multiplying there. So this notation means take whatever the f function is and put it into the g. So the f function is 3x, right? So you would pick up 3x, come over to the g, replace that variable with 3x. So my answer for 2 would literally just be 3x plus 2, and you're done. So this notation, I know it feels like multiplication, right? Because again, we're using the same, like we use parentheses to mean multiplication, but that's not what it means here when we are talking functions. So you have, you are taking whatever this function is and inserting it into the other one. I hope that makes sense. Okay, number 1. This notation, right, when it's written this way, I start with the function closest to the x, which is h. I'm going to take that and I'm going to put it into the g. So you should have picked up x squared and put it into the g function in place of that. So I pretend that that one's not even there, and then I replace it with x squared. So my final answer would be, yes, it's just x squared plus 2. Did you get it? Look at your papers. You got that one? Good. 2 we already kind of talked about. So this notation, it is, I mean, if you prefer, if you like one version over the other, you could just rewrite every single one. So it's always in the way that you like it. So this Here, I'll just put as a side note, this is the same as, you could have written this as g of h of x like that. This one, if you don't like it that way, it's the same thing as g open circle f of x. Okay. That's the same thing. So then this one would be h of f of x, if that's what you prefer. So you can always just take it upon yourself to just switch them if you don't like the way that it is, but you need to know how to do it. Okay, so any hoosers, my second one, I'm taking the f function, whatever it is, and I'm going to put it into the g. F is 3x. So I'm going to pick this up. I'm going to bring it over to the g. Instead of writing that, I'm going to write 3x. So I just get 3x plus 2. If there's anything to simplify, you simplify, but there's not in that case, so I'm done. And then the last one, remember what this means. Either way, the notation tells me take the f function and put it into the h. So I'm going to take the f function, 3x, and I'm going to bring it over, and I'm going to replace that variable with 3x now. So it looks like this. Does that make sense? And now I just have to simplify that. So what is 3x squared? 9x squared. Look at your paper and make sure you didn't leave it as just the number 3 and then x squared. Because think about what H is saying. H is saying take all of this and square it. So if you're going to replace that with something like 3x, you have to square all of 3x. 3x times 3x will get you 9x squared. So that would be my final answer. How do we feel? Okay-ish? So there was one more tiny piece that I wanted to do, but I also don't want to overburden you. So maybe, gosh, should I wait till tomorrow for that other little piece? Yes, okay, fine. All right. Okay, so any questions? You feel all right? I'm gonna give you your homework, which is just like what we just did right here. And I'm sure we can get it done. You guys got a good over 20 minutes here left, I think, so. So once we finish, your next quiz is going to cover sections 1 4 through 1 6. So this is 1 5. So we're about halfway through 1 5. And then we have 1 6 to do. So once those are both done, your next quiz will be coming. Man, I'm nervous it's going to end up being on a Monday again. I'm sorry. There's nothing I can do. Mother Nature is not cooperating. Yes. I thought we would, and now I don't think we will, unfortunately. So we'll probably finish what we need to Friday. And we'll close up on Monday. Yeah, my plan. Welcome. And 4, there you are. You're welcome. 1, 2. All right, let me stop this here.